Today we will take lesson 8.4 about polar bonds and molecules. Now miss, in chemistry actually we have four main types of bonds, or when they define the bonds they said that I have ionic bond, covalent bond, and we have hydrogen bond and van der Waals bonds. But because the van der Waals and the hydrogen bonds, both of them are types of covalent, so we will say that the main types of bonds, they will be ionic bonds and covalent bonds. Inside the covalent bonds, all covalent compounds, they have certain types of forces. Some of them, they have them all, some of them, they have some of or part of them. The main types of forces that there are for the covalent bonds, they are van der Waals forces and polar forces, non-polar forces, and hydrogen bonds. Okay? Now, when we are talking about van der Waals forces, the van der Waals forces, they have two types of forces, that they are the dipole and the dispersion. I will discuss them in details right now. First of all, the ionic bonds. The ionic bonds, you know that they are a combination between a metal and a non-metal cation that lose and an ion that gains, so they will make a neutral compound that does not conduct electricity unless it's molten or dissolved in water. Why? When I'm talking about covalent compounds, because there are many types of compounds and they have different ways in order to make them, so we don't have a certain trend for them to determine that all of them conduct, all of them do not, all of them dissolve in water, or all of them don't dissolve in water. In general, the covalent bond, you know that they are a combination between two non-metals or more. Now, let's take examples on covalent bonds in order to understand the forces that we have them for covalent bonds. Example that we have a certain, here we have a certain covalent bond between fluorine and hydrogen. Now, you know miss that fluorine has 9 electrons while hydrogen has only 1. So that means that the fluorine is stronger, or in another word we can say it is more electronegative. How we know the electronegativity? The electronegativity is given in your book in page 168 and 181, table 6.2. You will find the electronegativity numbers to compare them. Now, from the electronegativity and even in general, we know that fluorine is the most electronegative element. So all of other elements are much less than the fluorine. So I will say here that this electron that's given from the hydrogen, because the fluorine is stronger, it will attract to it. So I will say that the electron that's near to the hydrogen will be close to the fluorine and it will be far away from hydrogen. So the hydrogen will be slightly positive. This one means a slightly partial, or we can read it sometimes as delta. So this one is partial positive and this one becomes partial negative. When I have a partial charge inside the molecule itself, the partial charge is inside one molecule, the molecule itself, I will say that this molecule is polar. On the other hand, here I have the chlorine. Chlorine is an electronegative element, but here I have the same element. So it means the pull and push is the same from both sides. So none of them will be the winner. So the bond will be like shared between both of them. So here I don't have a charge and this one is nonpolar. The best way to determine if this compound or molecule will form a covalent bond that's polar is to know the difference in electronegativity. Now, if I compare the difference in electronegativity between two atoms and I got 0 to 0.4, it means it's nonpolar. If it's 0.4 to 1, it means it's moderate polar. If it's 1 to 2, it's a strong polar. And if it's bigger than or equal to 2, it's ionic. Now here you will say 2 is a strong polar and bigger than 2 or equal to 2 is ionic. So how do we know? How do we know? We know from the type of elements, because I don't have a sharp difference between the strong polar and the ionic. No sharp difference between them. So how to determine? If I have here two nonmetals, it will be strong polar. If I have here two metal or metal and nonmetal, it means it's ionic. So let's go back to the example, fluorine with hydrogen. Fluorine is 4, hydrogen is 2.1. The difference is 1.9, which means it's a very strong polar compound. NaCl, you know it's ionic. If we take Na, it's 0.9, Cl, it's a 3, the difference is 2.1, so it's ionic. Hydrogen, the hydrogen has 2.1, the difference is 0, 0 means nonpolar. So this is the best way to determine. On the other hand, sometimes the shape and the type of bond, they determine if it's polar or if it's nonpolar. Here, miss, I have CO2. The shape of CO2, it's like a linear shape. Now, CO, it's polar because C has electronegativity of 2.5 and the oxygen is 3.5. If we minus them, we will have 1. So it should be a strong polar. But this compound is nonpolar. Why it's nonpolar? Because the amount of pulling from both sides of oxygen is the same. This oxygen try to pull the carbon, and this oxygen try to pull the carbon from the other side, so they cancel each other. So I would say that this one is non-polar. While if we look at water, I have here hydrogens. The shape of water is like a pin shape, so the oxygen will try to pull the two hydrogens or the electrons that we have them from the hydrogens, and it will be a winner. We have here a polar compound. Why? Because for each hydrogen there is nothing of hydrogen to cancel it on the other side, and also I have here two unshared electrons that they will increase the strength of oxygen. So this one is polar. On the other hand, let's take methane. Methane, CH4. Methane is CH4, and here I have 4 hydrogen. Carbon-hydrogen bond is not polar, it is 0.4, and also CH4 also it's not polar. Why? Because all of them, they cancel each other. But if we have this one, CH3Cl, now these two H's, they cancel each other, but here I have H and Cl. I have to check, is CCl polar? Cl is 3, C is 2.5, it's half, so yes, it's a moderate polar compound. So this one will be polar. Now, the polarity of a certain compound, how we determine it? We determine it by the difference in electronegativity. The larger the difference, the more the strength. When I say that this compound is a strong polar compound, it means that this compound conducts electricity. How it conducts? Because of the partial charge that it has. Now, the van der Waals bonds. The van der Waals bonds, actually, they are bonds that we find them in all types of molecules, and they are weak. We have two main types of van der Waals bonds. We have the dipoles and the dispersion. The dipole force, they are attraction between two polar compounds or two polar molecules. So I'm not talking about the molecule itself. The molecule is already polar, but I'm talking about two molecules, because you know I can't make only one molecule. So if I have a certain container that has molecules of OI is polar because O is 3.5 and iodine is 2.5. The difference is 1, so it's a strong polar. So you will see that the partial positive from the iodine will be attracted to the partial negative from the oxygen in the other molecule. So I will see here that I have an attraction between different molecules. This molecule is already polar, and this molecule is already polar. The dipoles occur only on polar compounds, only polar. I don't have it when I have non-polar ones. What about the dispersion? The dispersion, miss, I told you before that the electrons are in a random motion, so I cannot detect the location of a certain electron. So these electrons, because they are in motion, they can make a certain force due to the acceleration of them. You know, force is equal mass times acceleration. So due to the acceleration of them, they can make a certain force between them. This force, I call it by dispersion force. To understand the dispersion force more, let's take iodine. Iodine is a certain element, and it is a halide, or we can say that it is a halogen. Now, the iodine, miss, it has a positive charge, which is the nucleus, surrounded by electrons anywhere. Now, at some moments, what happened? At some moments, because the iodine is a heavy element, at some moments we will see that the electrons, they will be accumulated in one area. So I will have many electrons in one area. So I will say that the atom will be temporarily polarized. How? Because I have here a positive charge in one side and all of the negatives in other side. When it becomes like this, it will attract another iodine ion, so it will make it induced polarized. It will be induced by this one. So the negative charges, they will be on this side and the positive on the other side. So here I have a certain dispersion force. How to determine the strength of the dispersion force? It's determined by the number of electrons. More electrons or more atomic mass or more atomic weight means more dispersion force. Now, the dispersion force means actually it's very important. Why? Because once I have more electrons, as you see here for iodine, you will see that the iodine becomes like a solid. While because the bromine has 35, it's a liquid. Chlorine and fluorine, they have small amount of electrons, 9 and 17, so they are like gases. So as it increases, the state of matter will be like a solid. Okay, now both the dipoles and the dispersion, they are van der Waals forces, so they are not different forces. Van der Waals forces, it's the name of the scientist, Van der Waals. Sometimes they call it by London force. Okay, London force, it's the same as Van der Waals force. The last type of forces is a hydrogen bond. What is the hydrogen bond? Hydrogen bond, it's a special case of the dipole's force, but this dipole's force occurs between two polar molecules. One of them at least should have hydrogen, and it should be connected to a high electronegative element like nitrogen, oxygen, fluorine, and so on. So if we take here fluorine with hydrogen and fluorine with hydrogen, the connection between the partial negative and the partial positive will be a hydrogen bond. Actually, the hydrogen bond is one of the most strong bonds. It's the strongest bond. It's stronger than the dipoles and stronger than the dispersion. The hydrogen bond, because it's very strong, it affects the melting point, the boiling point, and also the state of matter. So water, as you see here, because I have here partial negative and partial positive, and we have hydrogen atom, the negative from one oxygen will be connected to hydrogen, the hydrogen will be connected to oxygen, and so on among a certain molecule. So we will find that the water becomes like a liquid due to hydrogen force. All of the compounds that they have atomic mass near to water, the water is not that much heavy, it has two hydrogens. All of them that they have atomic mass near to water, they are not liquids, so they are gases. Except for water, it's like a liquid. Why? Because of the hydrogen force. Also, the hydrogen force increases the melting point and the boiling point. That's why we will say that the boiling point of water is 100, while most of the elements that they have hydrogen, the melting point of them is below 0. Or the ones that they don't have hydrogen bond, or they are not polar. Okay, the hydrogen bond, it should be between polar molecules. I can't say that I have hydrogen bond between hydrogen, like for example CH with CH, and I say here I have a hydrogen bond. No, because CH already is not polar. Okay, also the hydrogen bond, it gives the shape of the crystals of ice, because you know the ice, it has a hexagonal shape. Due to what? Due to the hydrogen bond. And also the hydrogen bond is the reason why the water expands when it freezes rather than it shrink. Why? Because this huge amount of forces, it tries, when I have it in ice, it tries to be far away from each other because I have a huge amount of force, so the distance becomes larger, so the water becomes larger when it becomes like ice. So actually we could not give a certain trend for the properties of molecular compounds. The molecular compounds properties are determined by the intermolecular forces. State of matter is determined by the molecular forces, boiling point and melting point. The conductivity, so the polars and the ones that they have hydrogen bonds, in most cases they conduct. Solubility in water. The polar compounds, they dissolve in water. Why? Because the water itself is polar. So polar dissolves water, like dissolves like. And even the hardness. How the hardness is affected by intermolecular forces. Actually, some solids, when I have them, the hardness, it's about solids. We don't have hardness for liquids and gases, only for solid. I said solid is hard. The hardness is affected by what? By the shape of the molecule. Now, some shapes of molecules, they are like linear. C, like this. Some shapes, they are like chains. C, and then connected to C, then go down, then go up. Some of them, they are much complicated, that they can shape hexagonal shapes or systems, or sometimes we call it by network. Here I have a network like C connected to C and then to connected to other C. So here when I have a network, or I have something that has a certain circular motion or circular shape, I would say this atom or this molecule will be very complicated. When it becomes very complicated, it means that this solid needs a huge amount of force to be applied on it in order to break each covalent bond between these molecules. What I mean by the amount of force that I should add, it is the bond dissociation energy, which is the amount of energy, amount of heat. So that means that the ones they have a chain shape, or sometimes that they have circular shape, chain shape, or even network shape, they have higher melting point and they have higher boiling point. Example is diamond. Diamond, miss, it doesn't melt easily. Actually, we could not melt the diamond. And when we apply a temperature of 3,500 degrees centigrade, the diamond will start to vaporize. It will sublimate. So the diamond is very hard. Why it's very hard? Due to the network system, the hexagonal, or actually it's not hexagonal, it's octa system, consists of 8 atoms that they are connected together, and also due to the high melting point of it and high boiling point, so it's a determination for the hardness of a certain compound. So most of the carbon compounds, they melt easily and they boil easily, like gasoline, like kerosene, all of them, they contain carbon. They melt and they boil at very low temperatures. But once I have a system that's made of chains or networks, it will be very hard to melt them. Thank you.